Welcome, my friends. In this video, I'll be discussing section 8.2, independent versus dependent groups. When collecting data for two or more groups through an experiment or otherwise, it's important to consider if the groups are independent or dependent. If the observations in one group are not influenced by or related to the observations in any other group, we say that the groups are independent. For example, a nutritionist wants to compare the BMI of male and female clients. Each group is independent. The BMI of a male client has no impact on the BMI of any female client. If the observations in one group are influenced by or related to the observations in another group, we say that the groups are dependent. Quite often, groups are dependent as the individuals for whom data are collected are the same in each group. For example, let's say that students take a pre-test on day one of the class and a post-test after the semester is over. The two groups consist of the same students on day one of the class and after the semester is over. Therefore, we say that the two groups are dependent. For example, if one student did very well on the pre-test, we might expect that that same student would also do very well on the post-test. So the result of the post-test depends in some way on the results of the pretest. The two main forms of dependent groups are repeated measures and matched pairs. Repeated measures is a special kind of data collection where the same response variable is measured many times for each individual, which is common in the medical field. For example, let's consider the repeated measures study here related to weight loss. The subjects would be originally weighed to find their baseline weight, and then they'd be put on some sort of diet, and then they'd be repeatedly weighed every so often, let's say every month. So the weight would be recorded after 1 month, after 2 months, etc., all the way until the 6th month. And then we might make comparisons between the different diet groups. Matched pairs, often called paired data, results from data where there is a specific reason to pair together data from the two samples. For example, consider the scores for a baseball team on a doubleheader, 2 back-to-back games. Since you're likely playing the same team back-to-back, there could be some sort of dependence on the two scores of the games that were played, and therefore it might make sense to pair that data together. Another example could be weight loss recorded both before and after a diet program. The before data is related to the individual before they have gone on the program, and then the after data would be related to the same person after the diet, so it makes sense to pair those numbers together. Another example could be comparing the unemployment rate in 2010 versus 2020 in each of the 50 states. Each sample relates to the same state, just in a different year, so it makes sense to pair those two values together. Here's another example. Grand Valley State University Department of Statistics Chair Paul Stevenson is an amateur golfer and is interested in comparing his play with professional golfer Phil Mickelson. While Paul has no illusion that he compares favorably to Phil, it would be somewhat amusing to contrast their respective golf games. One way to compare Paul's game to Phil's is to randomly select Paul's scores from 10 rounds of golf and compare them to 10 random golf rounds from Phil. Why are these groups independent? So think about that for a moment. Well, data is dependent if the results of one sample somehow affect or influence the results of the second sample. And Paul's scores do not relate in any way to Phil's scores. So we would say that these two samples are completely independent. Note that this is not really a reasonable comparison, as the rounds are random and not comparable. They could be playing at completely different golf courses, and it wouldn't really make any sense to compare those values. So let's consider a different situation. So suppose instead that Paul contacts Phil, and by some miracle, Phil agrees to play 10 rounds with Paul at 10 different courses. Their scores on each round are compared. Explain why these data are dependent. So take a second to think about that. Well, now in this case, we have the matched pairs situation, where each score can be paired. So we have the score at the first course for Paul and the score at the first course for Phil, and we could directly compare those values, and it would make sense to do that. So that's what makes this dependent groups. By playing the same courses at the same time, we have eliminated the lurking variable of possible differences in courses, allowing for a better comparison of the golf abilities of Paul and Phil. Alright, that's all I had to discuss in this video, so I will see you in the next one.